Welcome students. Today we will discuss about full blind search algorithm. This full blind search algorithm is used for optimization. Is mostly used for optimization. So what is optimization? Optimization is a process of finding the best value of x. I will write. Optimization is the process of finding the best value x star for which the objective function or you can say evaluation function, which is denoted as f of x, that means f dependent on x is maximum or minimum. So correspondingly we can call the optimization as maximization or minimization. I will tell what is optimization. Optimization is the process of finding the best value of x star for which the f of x is maximum or minimum. Okay. So as a first technique, you have to understand here in optimization you need to specify the objective function and you have to specify the input variables and their ranges. Okay, and their ranges, input variables and their ranges. So with the help of these two we can solve all types of problems. So in fact you can interpret the optimization of as a searching the best solution. Okay, searching the best solution for which our objective function attains either maximum value or minimum value. Okay, so this is a basic introduction for optimization. So let us see how optimization is performed for full blind search algorithm. Okay, we will go directly the algorithm. Full blind search algorithm. So in this algorithm, the inputs for this algorithm is a search matrix. That means you will have to specify a search matrix which consists of all the solutions in the space. Okay, this search is a matrix type which consists of all the solutions. So since it is a matrix, this matrix will have a size of number of solutions, that means the total number of solutions into d. D means number of variables. That means say for example x is the optimum solution, means generally x is a vector. This capital X consists of small x1, small x2 and so on up to small d. So each variable x1, x2, x3, it can be variables. It can take the range of values specified by the domain. Okay. After specifying the search matrix, the next step is the next input for this algorithm is the objective function which we have to give to this algorithm. Objective function, and then we have to tell whether we have to find the minimum or maximum. Minimum or maximum. So here the logic for this full blind algorithm is, it's a simple, I will tell. So in this FBS algorithm, you will store all the solutions in the matrix. That means your matrix consists of all permutations, combinations of the solutions, and then you will evaluate each solution in the matrix with the help of objective function. That means you will apply the objective function on all solutions and find the best value x star, or you can call it as an optimum value, for which you have the f of the function f of x is maximum value or minimum value. So it is a brute force technique. Okay, it is a brute force technique, but this is also one simple technique when you can use means if the number of dimensions is small, that means the number of variables are small and the range is small, you can use this algorithm for finding the optimum value. So the logic for this algorithm is, the working principle for this algorithm is, find all the solutions by using permutation and combinations and store it in the matrix, and evaluate all the matrix solutions and find the optimum solution. So let us write in the algorithmic manner. Now you will understand. So these are the three inputs you have to give. So correspondingly, the output what we will get means your optimum solution, and its corresponding evaluated value. This is how the algorithm works. Okay. So let us see. So this is the input for this algorithm, input arguments, and then the output arguments. Let us see the stepwise. What are the steps involved in this? In the step 1, you have to define the name of the algorithm. Let us see FB search, and you have to pass 3 arguments: search matrix, and the function, and then the type. Step 2, since we got all the solutions in the search matrix, our next step is to apply the objective function for all the solutions in the search matrix. So since we know the number of solutions as n sol, so you can put one for matrix, for loop, for I is equal to 1 to number of solutions number of solutions. You can apply, you can write as a step 3. This is a step 3 for I is equal to 1 number of solutions. You have to apply the function. You apply the function on the search matrix, search of it, and store the result in some array. Okay, result of I. Okay, and you can, in step 4, you can write end for loop. Okay, now coming to step 5. So we apply the evaluated function on all solutions in the search matrix. So I will write more clearly, you will understand. Result of I, and then so you can write for better understanding. Okay, so now the next thing, after computing the evaluated values, the next thing is you have to check whether we want the minimum value or maximum value, or minimization problem or maximization problem. So for that we are having the type. So you put one condition statement, if type is equal to min, then you write as step 5, step 6, this is step 6. Step 6, you want to find the minimum value in the result array. So you can apply some min function on the result array, and it will give you the both index, let us assume, and its value, index location, and the evaluated value. Let us suppose evaluated value. So once you got it, you can return, you can write in step 7, you can write return a list object. Let us write a list object comprises of the index, okay, that means the index of the array, and then the solution, which we call as a x star, is equal to, it is present in the search matrix, index, and then finally your evaluated value. If step 8, So in step 8 you can write end if statement, end if statement, or you can write directly next. Sometimes you want to find out the maximization also. So in such a case, you can write directly the else statement. So step 8, and again you have to find the maximum value. Okay, maximum value present in the result array. So in this case, you will apply the max function on the result array, and then you will get the indexing as well as its evaluated value. So this is step 9. Now we'll go to step 10. In this step 10, you will return a list object comprising of, so here you can close the list object, comprising of index is equal to id, and then solution is equal to index position corresponding to search matrix, and then the output value, or you can say the evaluated value is equal to. So this is about step 10. So it's a very simple algorithm. What we have done means, we have initially stored all the solutions with the help of permutation combinations in the search matrix, and then we have taken the objective function. Depending upon the type value, whether it is min or max, we are executing it, and then we are returning the as a list object. The whole process is neatly written in the form of an algorithm. So finally step 10. Step 10 is over. Stepplan, you can stop the end if statement. And in step 12, you can write end FB search algorithm. End search algorithm. So all these things you have to neatly write step by step. So for your understanding, I am drawing the lines. So from where they will. So here the end statement. So now you will understand what is happening in FB search algorithm. I will tell once again. So you have to give the input. A search matrix consists of all permutation combinations of the solution and the objective function and the type. We want whether we want to perform minimization or maximization. So in each step we are applying the function on all the solutions in the search matrix, and then we are storing in the result array, and after that, depending upon the type value, we are applying min function or maximum function to find out the required index locations. Once we got index locations, we can output the optimum solution and its evaluated value. So let us see one example so that you will have a more clear understanding about what is happening. So this is about so I want you can note it down. So I think it is very clear and it is easy to understand. So in this way you need to write neatly. Okay. Okay, let us see one example for this. Say for example, you are having a objective function of f of x is equal to small x1 plus small x2 plus x3. So where x1, x2 and x3 are binary variables, that means the range is only 0 and 1. So let us see how we can solve this function. So with the help of permutation and combination, so x1, x2, small x1, small x2, small x3. So since three variables are there, so this is our objective function f of capital X. Here capital X is equal to small x1, small x2, small x3. So here let us assume we want to find the maximization problem. It is one of the simple problem. So as for the full blind search algorithm, that is FBS, so what we have to do means we have to store all the solutions in the search matrix. So let us see one by one. So with the permutation combination, it is 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, and then there is another value. It is 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and finally 1, 1, 1. So just you need to evaluate the objective function for all these solutions. So this you need to generate yearly and store it in the search matrix, and then for each index location evaluate the function. So this for the first row it is 0, this is it is 1, so this is 1, 2, 1, this is 2, this is 2, and finally 3. So clearly which one is maximum? So this is your maximum value. Okay, this is your maximum value. So what I can tell is, so therefore this is your maximum value. So at this x star, that means 1, 1, 1, your function f of x, that is x1 plus x2, 3, it gets the maximum value of 3. So in this case we will call this x star as a optimum value. So this is how the full blind search algorithm works. Okay, thank you students.